let us start. So today will be the introductory class for integral calculus. Right. So in the integral calculus, the syllabus whatever we have is, that is, so indefinite integrals, infinite and improper integrals, so double and triple integrals, and then applications of multiple integrals, to find out areas and volumes. So this is the part of this syllabus. Got it? So in that syllabus, so this is indefinite integrals. So this actually you might have learned at +2 standard itself, and this was covered as part of the foundation course also. So we don't need to revisit that back again. And this is, so I don't expect actually any questions from this indefinite integrals, because this is at very substandard. So indefinite integrals, you should be already quite aware of it at +2 standard itself. Got it? And then, so you didn't even find at least one question for the past 10-15 years. So this particular section, right? So this is very lower standard, so you can ignore that. But you have to be aware of that to know all other things. So that's why it was covered as part of the foundation course. And then infinite and improper integrals. So this is also not part of integral calculus. This is part of real analysis. So it will be covered as part of real analysis, infinite and improper integrals. So to be specific, whatever we have is, that is double and triple integrals and applications of multiple integrals to find out areas and volumes. So this is the smallest syllabus whatever we have as part of this integral calculus. Got it? So whatever the knowledge that is required to understand this particular topic, right? So except for the +2 standard integration, so there is nothing else you need to understand this particular topic. So this is, which is the base or the fundamental topic. So that means you can start from this. So this is the base or the fundamental topic from where you can start your preparation, right? So without having any prior knowledge except for +2 standard integrations. Got it? And then here actually, so this particular topic is very important to understand vector calculus. So without having this multiple integrals, you will not be able to understand at least even a single concept in the vector calculus without understanding these multiple integrals. So this is very much needed to understand this vector calculus. Again, it is dependent on this vector calculus. Unless you understand the vector calculus, you will not be able to understand anything in fluid dynamics. Got it? So these are interdependent. Fluid dynamics is dependent on vector calculus, and vector calculus is dependent on multiple integrals and vectors. Got it? So this is how actually the order is. And here actually evaluation techniques of multiple integrals is very much needed to know this vector calculus. Applications also is needed, because finding out the areas and the volumes and integrals over the areas and integrals over the particular volume. So you have to do it to find out the fluid, so field related problems. So field related problems are dependent on these multiple integrals. So where this field is related for us is, this is the fluid field. So the fluid field is the fundamental topic actually which you need to understand. In this particular section, so this is part of the calculus syllabus itself. So calculus in total, it will be somewhere around 60 marks it will be given. Calculus in total. So out of that, so the questions may vary from differentiation and the differential calculus and integral calculus part of it. So at least you can expect 30 marks out of it. Got it? So this is as part of the calculus. So it will cover the calculus topic as a whole. That's why actually, so questions may be divided between the differential calculus and the integral calculus. So somewhere around 30-30 or 40-20. So this is how actually it can be varied. Got it? So this is the syllabus actually in general what we are going to cover it. And to be specific, this is very, very easy topic. So this is very, very easy topic. So this is where you can start your preparation actually from the scratch. Got it? And then one more important thing that you need to understand is that to solve these multiple integrals, one topic which you have to be very much clear, and that topic is not part of UPSC syllabus, and I have covered in detail to a greater extent in foundation course, that is the coordinate systems. So the coordinate systems actually you have to study thoroughly before solving these integrals. Especially finding out the limits is very tough in case of triple integrals or double integrals. Those integral limits you will be able to find out once you understand this coordinate system. So in that coordinate system, we have three different coordinate systems actually we have discussed. One is the Cartesian, and another is the polar, so another is the cylindrical, and the third one is the spherical coordinates. Now all the three coordinate systems actually you have to be pretty much clear, and all these aspects I have covered rigorously in foundation course. Go through those videos in case actually if you are not aware of that, so you go through that, then only you start attending these classes. Got it? So for today it's okay, I'll give you time tomorrow. So because today is just an introductory class, so before tomorrow's class try to go through the foundation videos. Got it? So any questions? So I think so you people have to be aware of the usage of the portal. So in that portal, right, so I'll just explain. I think so everybody has to be aware of that. I hope everything is noted down here. Got it? So once you log in, right, so many people are facing this issue, I think. In the web portal, right, so there are mainly two different aspects actually that you have to be considering. I'll just okay. So in the web portal, right, so there are menu items, that is home, course, downloads, prelims test and mains test. Right? So home, course, prelims test and mains test. So I'll just explain briefly how to use this one. So in that actually there is a course menu, right? And the course menu, once you click on that, so log in first with your username and password, go to course menu. In the course menu actually, so you will find two different sections. One is live classes and another is recordings. So in the live classes actually, so all the live class schedules will be displayed there. In the home menu also, live classes will be displayed. So you can join from here or you can join from here. So two options we have it. In the recorded section, you click it, and then there actually, if you click on this one, there will be two different menu items. You are going to get it. So this is the course menu item, and this is the paper or topic. And then here actually your course expiry date will be there. Here actually in the course menu, this is a drop down list. In this drop down list, all the list of, just if you hover the mouse here, you are going to display all the courses that are active for you. So there will be 3 different courses for all the students. So one course is mathematics optional. In that actually, if you select this particular course, by default this will be selected, or whatever the course that displayed first, it is going to be displayed. Now corresponding to this particular one, there will be a topic list that will be displayed here. If this is the course that you have selected, then here actually 2 different topics it will be displayed. One is paper 1 and another is paper 2. So if you select any of these paper, by default actually mathematics optional paper 1 will be selected by default. So then if this is the selection, the list of videos that are already covered in that particular topic, that is paper 1, whatever the course you admitted, right? So the list of topics that were covered, it will be displayed in a serial manner from bottom to top. So you can start watching the videos from bottom to top, but all these are mathematics optional UPSC syllabus related videos. Got it? And then here actually there will be one more course that will be there for everybody. That is foundation, maths foundation. So if you select this course, correspondingly here the items are going to be changed to maths foundation topic. Then there will be some list of videos. I think somewhere around 7 or 10 videos will be there. So those 10 videos will form the basis for the understanding of UPSC syllabus that I have covered. So before starting this course, got it? So there were 10 days actually I have taken to cover entire aspects of the fundamentals which are needed for understanding the UPSC syllabus. In that actually I have covered this topic, that is coordinate systems. So this foundation course you selected, automatically there will be 10 videos that will be displayed. You go through each and every video from bottom to top, you will be able to understand all the aspects that are needed. So but it is not part of UPSC syllabus. That is mostly from +2 standard. Got it? And then the third course will be maths test series. Maths optional test series will be there. So in this test series, so no videos will be displayed in this test series, because these videos are getting accumulated when we conduct the topic, so mock tests for you. So we'll be taking discussions. So in the live discussions actually whatever we discuss, that is going to be recorded and that will be displayed once you are done with the test series. Got it? So this will be coming only when you are running the test series. Got it? So these are the 3 different courses that will be there. So for each course actually the corresponding expiry date also will be displayed at this particular point. Got it? So this is how actually you will have to go through this foundation course. You select it. If not there, then you contact me. So it will be available for you. I will be giving to everybody whoever is joining the course. Clear, Midun? And then there is one more. This is the mains test series. So this will be active only when you are running the test series. That is, when we run the test series, whatever the test we publish, so that published test will be there at this particular menu tab. So list of tests will be published here. So one by one. So each week actually there will be one test that is going to be published, but this is only when the test series is running. That is mostly after January. So if there is a test series that is running for you, then actually the test will be appearing there. So each test actually there will be different options. One option is the question paper will be there. So the menu items actually in one particular test, right? So question paper you can download it. There will be a menu item there. So there will be a button which you need to click to download the question paper. So then you can answer the question and then you can scan your solutions. All the solutions you can upload there only. There will be one more button to upload the solutions. You click on that, then it will ask you to upload the paper, right? So that uploaded paper so will be evaluated for you, and then we'll be giving the comments on that. Those comments actually, once we give the comments, we'll re-upload back to your login account. So that will be displayed again after the comment section. Got it? So immediately when you upload the question paper solutions, right? So you will be displayed with the reference solutions. Immediately once you upload it, you will be getting the solution then and there itself, so that actually you can check your answers. Got it? So this is the mains test series. So these are the 2 different aspects actually you have to be aware while using the web portal. Got it? If you want to know the syllabus of mathematics optional, then that will be available without even logging to the website. So outside pages actually there will be mathematics optional course. There actually we have listed the entire syllabus each by topic by topic. Got it? Understood? Any questions? Okay. So this is how actually you can access all the foundation videos. Okay. Now in the integral calculus, now actually we'll start with the topic itself. I'll just introduce what is this integral calculus. So here actually derivatives is nothing but it will be talking about only about the changes in the functions. So if you know this particular function y is equal to f of x, y is equal to f of x, so this is a function, right? So x is an independent variable and y is a dependent variable. Now this will give you a relation between these two. So this relation, let us say this is the relation. So this function is y is equal to f of x function. Now I am not concerned about this particular function, but what I am concerned is if there is a change in the value of x, how this y value is getting changed. That means I wanted to correlate the changes between these two. That means if there is a change in the value of x, what will be the corresponding change in the value of y? If I wanted to establish a relation between these changes, and that changes actually we have given a separate definition, that is dy by dx. So dy by dx is nothing but limit delta x tending to 0 delta y by delta x. So this is how actually we found the relation between the two variables. Here see this is relation between x and y, but this is the relation between delta x and delta y. So it will give only the relation between the changes, not the function. Here, and this change actually if you plot it, this will be the dy by dx graph. So that's why this can be written as delta y is equal to g of delta x. So this is nothing but dy by dx. Got it? So dy by dx is a relation between delta y by, so delta y is a function of g of delta x. So this is what is defined as the derivative, and the fundamental definition of the derivative will be limit delta x tending to 0 f of x plus delta x minus f of x divided by delta x. So this is how we define the fundamental derivative. So this derivative will form the basis to understand the integration. So the integral is nothing but exactly the inverse of the integral. So inverse of the derivative. So here dy by dx or d by dx of x power n is equal to n into x power n minus 1. X into, so n into x power n minus 1. Now here actually while doing the integration, we take this x power n on this side and dx onto the other side. N into x power n minus 1 into dx. And then we use a symbol called integral symbol. So this integral symbol, if you put it on either sides, then this derivative and integral will form the opposite definition to each other. That means integral is nothing but antiderivative. Antiderivative meaning these two will get cancelled out because one is the inverse of the other. Then x power n will be left over here, and then n into integral x power n minus 1 into dx. And then this n being a constant, you can bring it here. This is how an integral is defined. So this is an antiderivative. Got it? Now, what is this physically means for us? That is, there is a function x power n minus 1 here, and there is a dx here, and there is a symbol, and which is giving some result. Now, let us interpret this particular one physically what is happening in this. Got it? Now, let us take a simple function y is equal to f of x here. And y is equal to f of x, that is nothing but a functional relation between x and y. Now, let us take between two different limits. Let us say from a to from b. From a to b. So a to b, you are trying to plot this particular graph like this. And this graph, if you notice, I have divided this into n different equal parts. So n parts I have made. N parts I have made. Now these n parts, each part of length dx. Each part of length dx. Now this is, let us say from this particular point, I call this as x1, and this is x2, and this is x3, and this is x4, and this is x5. Now here I have made 5 equal parts, and each part what I have done, I found the value of f of x1 here, and then I have multiplied this to dx. That means f of x1 into dx plus, again I took the second part, that is f of x into dx. I am doing it, right? So integral is f of x dx. For this particular function, if you want to do it, this is dx getting multiplied by the function value at this particular point. Similarly, same dx is getting multiplied by the function value at this particular point, that is f of x2 into dx. Similarly, f of x3 into dx plus f of x4 into dx plus f of x5 into dx. Now, all the sum together, we have given a definition called integral. So this is the basic definition of integral. So here, what is the meaning of integral? So integrate or integral. Integral meaning the sum or the addition. Here, integral means sum. So in the sum, the first letter is nothing but s. So that s actually is enlarged like this, and this was given as the meaning of integral. So this s is taken from this particular sum. So that is how actually we have got the integral symbol. Now integral f of x dx is nothing but it will be giving the functional value getting multiplied by dx, and all such kind of strips you are adding it. Now each strip is associated with certain area. That is why if you multiply the function value and the dx value, it will be giving the strip area here. And all such kind of strip areas are added together. It will give the entire area between these two. So that's why integral f of x dx is nothing but the area under the curve f of x between the x-axis and the function. Got it? So this is how actually you will be giving an application for this particular integral as an area. Got it or not? Understood? So here actually, if you notice one important aspect in this particular function, what is happening is so this is the function. This is the function, let us say. So this particular function I have divided into n equal parts, let us say, between two different parts. So this is x1 and this is x2 and this is x3 and this is x4 and this is x5 and this is x6. Now if you notice, when I took the area here, I have taken the f of x1 value getting multiplied by the dx value. So this is the dx value. Here, this part is coming an extra area. So, or actually, this part actually we are ignoring to consider the area. Now, same is the case. In the second case, actually, this is the area actually you are multiplying, but you are ignoring this. And even here also, you are ignoring this. And here, you are ignoring this. And here, this is okay. And then here, what is happening is, you are multiplying with the opposite one, right? So that's why this part is coming extra. So this is extra and this is ignored. That's why, so this particular sum, whatever we are taking, right, this will be more meaningful or accurate only if dx tending to 0. So if I make dx tending to 0, I can make this particular strip of infinite number. So if I can make it to infinite numbers, then each strip is almost very close. That is, if this is the function, so very next moment actually we have one strip. That means there won't be any area I'm ignoring or any area that is getting counted extra. Like this actually, if I make infinite number of strips like this, all the sum together, it will be given as the accurate area. So that accurate area is nothing but limit f of x dx. Here actually, this particular function, if you take it, that is, I'll take equal parts of n. Then each part dx is equal to 1 by n. each part. Dx is equal to 1 by n. Now this particular function value f of x1 into 1 by n plus, so here x1 is nothing but which is at a distance of 1 by n. So x1 I can treat as 1 by n. And similarly, this particular value f of 2 by n, and this is f of 3 by n, and this is f of 4 by n, and this is f of 5 by n. Right? Now here 1 by n times of f of 2 by n plus 1 by n times of f of 3 by n, 1 by n times of f of 4 by n, like this, whatever may be the number of parts it is. So it is going to be extending like this. Now in general this can be written as, this is sigma r is equal to 1 to n, 1 by n times of f of r by n. And this is the sum of the strips. This is the sum of the strip. Now in this, if this n value is being infinite, then we say that this as the integral of f of x dx. So for this, if you take limit n tends to infinite, this will be treated as the integral. Got it? Understood or not? So this is how an integral is coming with an application of area by default. Clear? Okay. So now here actually, whenever we do certain integral f of x dx, right? So let us say integral x square. What is integral x square dx? What is integral x square dx? Can somebody give me x cube by 3? Is that x cube by 3 or there is something extra? Plus c. So this is very important. Now why this plus c? Why we have to keep plus c always? Exactly. So differentiation of constant is 0. That means, so if you take integral x square dx, so this is nothing but integral x square plus 0 into dx, or this is integral x square dx plus integral 0 dx. So integral 0 dx is nothing but, so the derivative of constant is 0, then integral of 0 will be constant. Is there any difference between area and integration? So integration is a master and area is one such kind of application. Got it? So by definition, integral is nothing but the antiderivative. But one of the application of the antiderivative is to find out the area. But it has lot many other applications as well. It's not same. Got it? Got it? Okay. So this constant that will be coming extra. That's why we always keep plus c in case of any indefinite integration that we do it. Now the same integral, if I take integral a to b of x dx, now here actually when we do the integration we don't consider plus c. Why? So in indefinite integrals only we take plus c. In definite integrals we don't take. So why? Exactly. So it gets cancelled out. So this is, let us say we have got g of x as the answer, then upper limit will be and lower limit is a. Then ideally this is g of x plus c and the upper limit is b and lower limit is a. Then g of b minus plus c minus g of a plus c. So this c and this c will cancel. Finally g of b minus g of a will be left over. So that's why we don't consider plus c in case of definite integrals. We do consider plus c, though it is not there. So because in the indefinite integrals, so you have to consider plus 0 always. For that 0 integration, you will be getting the integral value as the constant. Got it? So these are all only the fundamentals. So all these are from plus 2 standard, whatever you need to be learning. Got it? Now coming to our syllabus, we start with the double integrals. Got it? So double integrals. So double integrals is nothing but, in this what we are doing is, suppose we know that, so the function y is equal to f of x is given, and then area under this particular curve. So if you want to calculate, we will be straight away doing that integral f of x dx. Let us say if it is in between a and b, then integral a to b f of x dx is nothing but the area under this particular curve with respect to the x-axis. This is very crucial. So the area under the curve and the x-axis. So this is the area which we are talking about. Now, what if I wanted to identify an area which is of having two different shapes, that is f of x and g of x like this, and then here actually I wanted to identify the area. Now for this particular area, how I wanted to do it? So this is nothing but, I will calculate the area under the bigger curve, that is f of x, and then I will subtract the area by the lower curve. So that is minus integral same limits a comma b, but g of x dx. So this will give area between f of x and g of x. This is the area between f of x and g of x. Now, why do I need to write it in this particular format? Rather than that, I have a different method, that is integral a to b. Then the y value also, what I will do is, the variation is between the g of x to f of x. That's why I keep this as g of x to f of x, and then dx dy I take it. Now here there will be a variation in y, there will be a variation in x, and the variation of y is in between g of x to f of x, and the variation of x is in between a to b. And this is how you will be expressed in this particular integral. Essentially, you are intended to find out the area between the two different curves, and two different curves area will be calculated with x one set of double integral, that is integral a to b, which is nothing but the x limit, and then g of x to f of x, which is nothing but the y limit, and dx dy. This is how you will be essentially doing the same purpose what we are doing with the help of a single integral. Got it? Now here, this is, here actually the complexity involved in double integrals or triple integrals is identifying the limits. Now in the identifying the limits, here actually the order of integration when we take it, g of x can be expressed as y1 equal to, and f of x is expressed as y2 equal to. If I say y1 equal to or y2 equal to, the same limits will be there. If it is y here, it will be y limit only here also. That means if y equal to is given, you need to do the integration with respect to y first. Got it? So there will be a confusion which one you have to do it first, whether I need to do the integration with respect to x or y. So you have to do with respect to y. Why? Because the limits are given y here. Suppose the same integral value, if I wanted to do it in a different manner, that is between the two different curves actually it was given. Rather than that, I can express these values. Suppose I have a different set of curves like this. Now here, this is f of x, or this is h of x, and this is k of x. If this is the curve, then here actually you will be identifying the limits, this as the x1 and this as the x2, and the limits are in between a comma b. Now this is the area you wanted to identify. For that, what you need to do is, here try to express this particular function as x equal to, that is x is equal to some function p of y, and then here x is equal to some function q of y. Now here the limits are from a to b. This integral, the way you write it is, the limits are a to b, but y is equal to a to y is equal to b, and the function value is the left limit, that is the lower limit is q of y, to the upper limit, that is p of y, and then dx dy. But you have to do the integration with respect to x first. Why? Because this is x equal to. Got it or not? So based on this particular function, you will be identifying which one you have to do the integration. Got it or not? So, but the integration is as usual, as if like in case of partial differentiation, we take one variable as constant and the rest of, so one variable as the variable and rest of the variables you treat as the constants. Exactly in the similar manner, when you are doing the function with respect to y, you have to treat x as constant. if you are doing with respect to x, you have to treat y as constant. And then once you are done with dx here, so substitute the limits in terms of y. Then these values, whatever you substitute here, so you will have to do the integration with respect to y and then substitute the constant limits. Here the fundamental condition is the first and foremost limits will be always constants. So these are always constants. And the inner one, you have the flexibility of having constants or variables. Constants or variables. And then if it is constants, then well and good. If it is a variable, it will be definitely, it should be a function of this particular limit. That is, it should be f of y or q of y or p of y like this. It should be of y, but it should not be x. So that will be decided by this one. So y equal to a here, that means this has to be definitely q of y or p of y like this. That means it should be definitely x equal to. This is how you have to express it. Got it or not? So in double integrals, it will not be much, so it will not be so confusing. But in case of triple integrals, it will be a little confusing. Because in case of triple integrals, what will happen is there are three different integrals here. Now, this innermost integral will be a function of two different variables which are given by here. And the last one will be always a constant. And the middle one will be a function of one variable alone. That means if this is z, it will be a function of x comma y. And the middle one, if it is function of x, then the last one should be the y limits has to be there here. Last one. So this is the order. It is a function of x comma y, but it is a function of x alone, and it will be a constant limit. Or it will be a function of x comma y, and it will be a function of y, and it will be the constant. So x is a constant. Got it? So here the last one is having the flexibility of having both the variables. Suppose if it is four different integrals are there, so all the three different variables can be involved in the last integral. Got it? So whatever is there here, but if two different variables are involved here, so this has to be expressed as z is equal to some function of x comma y. That means dz you have to do it first, and then substitute this function of x comma y in this, and then come back to the second integral. So if it is a function of y, then it will be definitely, so if it is a function of x, it will be definitely y equal to, then you have to do the integration with respect to y next. Then the last one will only be x equal to, that means you have to do the integration with respect to x. So when we are doing this integration, you have to treat all other variables as the constant. So this is the rule to find out the integral value in any case. Got it or not? So this is the fundamental theorems what you need to understand to solve any kind of integrals. So double integrals or triple integrals or any number of integrals, it will be the same procedure. Only thing is you have to appropriately identify the volumes. So the difficulty here it is, so the difficulty whatever you face here it is identifying the shapes and the volumes. So identifying the shape. So this is where actually you face a little difficulty. That is, suppose if I say that x plus y is equal to k. So in two dimension, what is the shape of this? X plus y is equal to a, let us say. What is the shape of this? What is the shape of x plus y is equal to a in 2D? It will be a straight line, right? So x is equal to minus y, then it will be a straight line like this. Now, suppose if I say the same equation in 3D, what it will do? So this is z, or actually this is x. So what is the shape of this curve x plus y is equal to a in 3D? Same curve. So it will be a plane. That makes a lot of difference for us. So here x plus y is equal to a means it is independent of z. If it is independent of z, so at any point of z, at z is equal to 0 it will be a straight line, at z is equal to 1 it is a straight line, at z is equal to 2 it will be a straight line. Whatever the value of z, it will always be a straight line. All such kind of straight lines if you join together, it will form a plane like this. So that plane will be like this. So my hand here, it will represent the plane. So this is the plane actually we are talking about, x plus y is equal to a. So this you have to model as a plane. In case of 3D, you have to model as line in case of 2D. Similarly, suppose if I take this equation x square plus y square is equal to a square, what is the shape of this in 2D? What is the shape of this x square plus y square? It will be a circle, right? Now the same circle in 3D, how it can be modeled? It will be a cylinder, right? So yeah, it will be a cylinder, right? So that's the difference. So it will form as a cylinder. So in xy plane it will be a circle, but this cylinder is extended from minus infinity to plus infinity of z value. So here it will be a simple circle like this. So that is the difference. Now the way he describes the problems is, so he will be giving the intersection of one sphere and one cylinder, or the intersection of one plane and one cylinder, the intersection of one sphere and a plane, like this actually he will be giving. So that is, suppose if he talks about a cylinder, so that cylinder is nothing but, this is the cylinder, and then on this particular cylinder he says that there will be one plane cut like this, and then there will be one plane which will be given at z is equal to 0. So this is z is equal to 0 plane. So z is equal to 0 is nothing but a plane. That means that plane is nothing but the xy plane. So if he says z is equal to 0 plane, that means you need to identify this as the xy plane, and the xy plane here it is z is equal to 0, and then from there will be a cut off plane like this. So this is the volume that we have to be identified. To identify the volume, the cut between the cylinder and this particular plane and z is equal to 0 plane. So this is how actually you have to identify the volumes. So this is the difficulty that you are going to face it in case of double integrals and triple integrals. Only the identification. Once you identify this, then actually you can identify the limits where you need to integrate it. So this integration will be easier. Integration is not difficult. Identification is a little tough. And then, so to make it much more complex, he will give in polar coordinates or the cylindrical coordinates. So that will be a little complex. That is, the conversion from polar to cylindrical or cylindrical to polar, or actually, sorry, cylindrical to spherical and spherical to cylindrical, or Cartesian to cylindrical and cylinder to Cartesian. Like this actually, if you are very much rigorously known about these aspects of conversion from one to the other, then the identification of the volume along with the conversions will give you a lot of clarity on these triple integrals. Got it? So once you understand this, then only you will be able to solve the double integrals or the triple integrals. Once you understand double integrals and triple integrals with application, then only you will be able to solve the vector calculus. Got it? So this is the order actually which you have to follow. So based on this understanding, I'll be starting with the double integrals tomorrow. So those double integrals, you should not miss it. Got it? So then actually from there, I'll take it up to next level. Got it? So any questions on this? Any questions on this? Anything you wanted me to tell? Okay. Yeah. So that's all for today. So thank you. Yeah, good night. So tomorrow onwards, so it will be starting with the double integrals. Yeah. Thank you. Good night. Bye-bye.